Hi, in this video I'm going to give you some information about the scale invariant feature transform introduced in the week 3 lecture. So first of all, we come to the SIFT extreme detection part. Before we start this part, I hope you guys can remember the ideas, the definitions here. So let's start from the scale space of the image part here. So I would like to give more information about the Gaussian scale sigma here. So the first image with the normal sigma, and the second image would be multiplied by the multiplicative factor k. So k here is defined by the user, but we give out a classic combination here would be k equals to the square root of 2, and sigma would be 1.6. And in the coming layers, its sigma would be k times of the previous previous image's sigma. And then with this, we are able to calculate the scale space extrema by subtraction. So this idea is inspired by the difference of Gaussian. The formula is given here, and eventually it's in the format of this. So remember this part as given above. It is the scale normalized Laplacian of Gaussian. We just have a general idea here would be sufficient, and we also have the constraint of k equals to 2 to the power of 1 to s, while we should have s plus 3 images in each stack. I mean, the stack should be an octave here. So here's the octave. As s here equals to 2, we have 5 images in this octave. Now let's come to the keypoint localization. So given the vector x equals to this, xy would be the coordinates of the points of each point in the image, and the sigma would be the sigma in the Gaussian distribution. And based on the scale space extrema here, we can bring it down to the keypoint localization part. And by setting this to be 0, because we are getting its derivative, and now we have this. Sorry for any misunderstanding, I should remove this part. So after calculating the x vector here, we can get the key points. So this part is solved now, and as for the second part, the Hessian analysis, we should interpret as for each key point, we generate the Hessian matrix. For the calculation of Hessian matrix, you can look up on Google to search how to do that. But the main idea would be with such a Hessian matrix H here, we self-define a threshold R, and the trace of the Hessian matrix, the square of it, and the determinant of H. So the ratio of here should be smaller than this. So if it's smaller than this, we reject it. We reject it as a low contrast and edge points. Hope this video clarifies what the SIFT keypoint localization is. Thank you.